The next topic will be some details of the ear. First, we will be looking at some embryology, and then we'll talk about the external ear, middle ear, and inner ear details. You see, during development, I have told you that there is a neural plate ectoderm, and which will form the central nervous system. Then there is neural crest cells which are contributing to peripheral nervous system, and there are some ectodermal placodes also. These ectodermal placodes were helping neural crest cells to form some of the ganglia, because some of the ganglia are not purely from neural crest cell, they have contribution from ectodermal placode also. So most of the ganglia come from neural crest cell, but some ganglia have neural crest cell plus ectodermal placode contribution. This time I'm telling you, ectodermal placodes can also form, see here, otic placode. This is some ectoderm forming otic placode. And why do we need otic placode for? You see, day number 20, you're having otic placode on the ectoderm. Where? Surface ectoderm. It is, these placodes are distributed among the surface ectoderm cells. So they are distributed among the surface ectoderm cells. Are they surface ectoderm? No, they are not surface ectoderm, but they are distributed among the surface ectoderm cell. So ectodermal placode, what is it doing? See here what is doing. Otic placode will form otic pit, and otic pit will form otic vesicle, and otic vesicle will form inner ear. So first I have some otic placode. Yes, it is not surface ectoderm. No, it is not surface ectoderm. It is ectodermal placode. And then it is forming some otic pit. Yes, otic pit. And then it is forming some otic vesicle which will form inner ear. Yes, inner ear. Okay. Then we will form external ear. External ear we'll see, but first you see inner ear. Okay, what kind of section was this? This was a transverse section at the level of the developing ear. Okay, fine. What is the next thing? Next thing you will see, the otic vesicle is forming inner ear. And what is there in the inner ear? There is a vestibule which is utricle and saccule. So there is some vestibule which is utricle saccule. Yes. In the inner ear, there is some vestibule which is utricle saccule. Yes. What else is growing? Is actually three semicircular canals and cochlea. Cochlea also. Yes. Okay. So we're telling that there will be three semicircular canals and cochlea also. I think cochlea is spiral. Yes, it is spiral. Cochlea spiral, and even these are spiral, these semicircular. Then what is this? This is vestibule. And what is in the vestibule? You just saw what? Two components. What are the two components in the vestibule? You just saw here, utricle and saccule. Oh, that is utricle saccule. This inner ear is forming now. Yes, from the otic vesicle. Yes. Okay, what is happening next? You see, this is the ectodermal placode which are forming the otic vesicle which will form the inner ear in the territory of hindbrain. Where? In the territory of hindbrain. So ear is developing in the territory of hindbrain. Yes. And what else is, what else you already know? Some details. What do I know? Do you remember there was a pharyngeal cleft 1 lined by the ectoderm, surface ectoderm? Sir, this is groove. Yeah, groove doesn't matter. It is groove or cleft is same. So this is pharyngeal cleft 1. Yes, lined by surface ectoderm. I think it is forming external auditory meatus. Yes. Who is forming middle ear cavity? Middle ear cavity, I remember. Endoderm of the pouch 1. Yes, it is endoderm of pouch 1, but partly contributed by pouch 2 also. So pharyngeal pouch 1 plus pouch 2, but mainly pouch 1. Yes, it is endoderm of pouch 1, but also contributed by pouch 2 partly. chiefly pouch one. What is it doing? Forming the tuber tympanic recess and middle ear cavity and eustachian tube. What is that? Middle ear cavity and eustachian tube. Okay, then where is the eustachian tube opening? Let us see where is it opening. You will find the next diagram now. You mean to say this one? Yes. Can we magnify it? Yes, let us magnify it. Do you remember where is the malleus, incus and stapes bone coming from? Malleus, incus and stapes bone. Yes. Do you remember? Pharyngeal arch bones. Yes. Do you remember? I think malleus first arch and incus first arch and stapes second arch. Correct, you are. Malleus and incus will come from the first arch, stapes will come from the second arch, but from where? Secondary mesenchyme, neural crest cell. So they are coming from secondary mesenchyme, neural crest cell. Yes, in a cartilage. Names. First is Meckel's cartilage and second, Ricketts cartilage. You remember Ricketts cartilage? R-E-I-C-H-E-R-T. Yes, Ricketts cartilage. So second is Ricketts cartilage will form the stapes. Yes. Now, when the Ricketts cartilage form the stapes, there is a question asking who is forming the foot plate of stapes? You say foot plate of stapes is formed by Ricketts cartilage, but the outer margin is formed by otic cup, otic vesicle. So stapes foot plate is formed by Ricketts cartilage? Yes. But the outer margin is formed by otic cup, otic vesicle? Yes. And what if I have to choose one only? Why? What is the question? Who is forming foot plate of stapes? If somebody asking who is forming foot plate of stapes, then you should answer neural crest cell, secondary mesenchyme, Ricketts cartilage. And what if somebody asking the margin? Then it is the otic capsule, otic cup. The one which form inner ear? Yeah, the one which form inner ear. Okay, this one. Yes, this one. So this one will form the margin of the foot plate of stapes? Yes, not the foot plate itself. This is not forming the foot plate of stapes itself, just the margin. Okay, fine. I'll remember that. Now what? Now as you proceed further, you will see the further details. What is happening? You see what is happening now. This part of the diagram? Yes. Okay. So what is there in this part of the diagram? You see what is there? You will find that this is the surface ectoderm, yes, forming the external auditory meatus. Okay, that's the middle ear cavity and eustachian tube, which came from pouch 1. So telling that this came from pharyngeal cleft 1, this is pharyngeal pouch 1, yes. Endoderm of pouch 1 forming middle ear cavity epithelium and epithelium of the eustachian tube, whereas epithelium of the external auditory meatus is any external opening is lined by surface ectoderm, and then malleus incus stapes coming from neural crest cell. If malleus incus stapes is coming from neural crest cell, what is the stapes doing? Stapes is knocking on the inner ear. If you say stapes is knocking on the inner ear, where the stapes was present? In the middle ear. So this is middle ear, yes. Ossicles are in the middle ear, yes. I think malleus incus stapes are adult size at birth. Yes, they are. They are adult size at birth. Middle ear cavity is adult size at birth, but the eustachian tube was growing after birth, if you remember. So what is this? This is the otic vesicle forming inner ear. So you want to knock on the inner ear. Yes, how will you knock? Actually, there will be one oval window, and that oval window stapes foot plate will fix, and it will knock the oval window. So send the vibration into the endolymph of the otic vesicle. So it is knocking on the oval window and creating some vibration in the endolymph of the inner ear. Yes. Okay. What is this round window for? Round window is when the knocking vibrates, it will dissipate at the round window. You mean to say you have knocked and some vibration were there? Yes. And those vibration must be dissipated backward. Yes. At the round window. Yes. I cannot see anything here. Yeah, because it is still developing, that's why. Okay, then what is the next thing? Next thing you see here, what is this? This is the external ear meatus lined by ectoderm. This is middle ear cavity lined by endoderm. But what is the tympanic membrane lined by? Tympanic membrane, the three-germ layer? Yes. You have to understand that the outer epithelium of the tympanic membrane is ectodermal. Inner epithelium of the tympanic membrane is endodermal. But if you talk about the connective tissue of the tympanic membrane will be mesodermal. And what is the next thing? Next thing is when the inner ear is developing, it will develop endolymph, which need some vibration to detect the sound. Okay, so telling that aortic vesicle formed some inner ear will develop some endolymphatic. Who is secreting endolymphatic? Endolymph, there is some blood vessels they will secrete in the inner ear. Yes, in the inner there are some blood vessels. You mean to say there's some ultrafiltrate of blood like CSF? Yes, it is ultrafiltrate of blood like CSF. Endolymph is like CSF. It will drain into CSF. So endolymph will drain to CSF. Yes, how? That will find out. But this is inner ear and it is forming some membranous labyrinth. So inner ear is forming some membranous labyrinth. Yes, inside the membranous labyrinth is some endolymph. Yes. What about the bony labyrinth? Bony will be bony outside. So bony will be bony, it will be outside. Where is bony labyrinth? I cannot see. Yeah, because it is still developing. That's why you cannot see. So what is between the bony labyrinth and the membranous labyrinth? The perilymph. Oh, first you have endolymph. Yes. Inside the membranous labyrinth of the inner ear. Yes. Surrounded by some perilymph. Yes, and which is surrounded by some bony labyrinth. Yes, where is the bony labyrinth? I can't see because it's still developing, you know. Okay, then this is middle ear cavity. Yeah, of course, this is middle ear cavity. It is adult size at birth, and malleus and stapes are adult size at birth. Okay, if you say so. What is the next thing? Next thing, you see the adult ear. This is external ear, auricle, pinna, and external meatus, and this is the external ear canal, and the boundary line with the middle ear. Who is that? Tympanic membrane, which is lateral wall of middle ear cavity. If tympanic membrane is lateral wall of middle ear cavity, then what is the roof? Roof, you remember? Tegmen tympani, separating from the brain. Then what is the anterior wall? Anterior wall is communicating with eustachian tube. And what is the medial wall? Medial wall is the inner ear. So you are talking about the walls of the middle ear. Yes. Roof is tegmen tympani. Lateral is tympanic membrane. Anterior is eustachian tube. Medial is inner ear. What is it doing to inner ear? First of all, you tell me what is there in the inner ear. I think there is a cochlear nerve for hearing. Yes. And then there is vestibule, which is for balance. Yes. Utricle saccule. Yes. And semicircular canals also. Yes. For circular motion. You mean to say angular motion? Yes. Angular motion. What are they doing? See what they are doing? They are making some nerve. What nerve? Vestibulocochlear nerve. You mean to say vestibule is giving balance to the vestibular nerve. Cochlea is giving the auditory information to cochlear nerve. Vestibulocochlear nerve. Yes. Where is vestibulocochlear nerve passing? Where is vestibulocochlear nerve passing? It is passing towards the brain. Yeah, towards the brain. But where is it passing? Where is it passing? In the internal auditory meatus. It has to pass the internal auditory meatus to go to the brain. So they are going to brain now. Yes, balance and hearing and balance. Okay, fine. So there is outer ear. Yes, pinna and external ear canal. And there's a middle ear. Yes, where you have malleus and stapes. And there's inner ear. Yes, that is where you have cochlea and vestibule and cochlea. And also semicircular canals. Okay, fine. Can we look at the developing auricle? Because there are questions. What question? There's a question asking about the developing auricle. There are 6 auricular hillocks. Who is contributing where? You are talking about these 6 auricular hillocks to form auricle. Yes, actually, there's arch number 1 and arch number 2 contributing to auricle. The first arch will give the first 3 auricular hillocks, and second will give the next 3 auricular hillocks. Total 6 auricular hillocks are there. Yes, total 6 auricular hillocks are there. Now see, first arch give the first 3 auricular hillocks and it will form anterior part of auricle. If you are telling it is forming anterior part of auricle, will it include tragus or not? Yes, of course it will include tragus because you are telling anterior part of auricle, but major contribution by second arch. So tragus is contributed by first arch, but the major contribution by second arch. Yes. What is second arch doing? Second arch is giving the next 3 auricular hillocks. And what are they doing? They'll form the major portion of the auricle. How? See here. So you are telling that second arch will give the next 3 auricular hillocks from the major. Can you specify which part? Outer part, peripheral part, especially ear lobule. So you're telling that ear lobule is from second arch. Yes. And tragus is from first arch. Yes. Tragus is first arch. Can we see it again? What? The auricle development? Yeah, okay, see, but tragus is by the first arch and lobule is by second arch. And this is the other diagram. You understand that there are 3 auricular hillocks from first arch, 3 auricular hillocks from second arch, and tragus is found by first arch and the periphery is found by the first arch. Then what is the second arch doing? Second arch is auricular hillocks number 4, 5, 6, and it is forming the inner part of auricle including the ear lobule. So ear lobule from second arch. Yes. And tragus from the first arch. Yes. Tragus and peripheral part is from the first arch and inner part and lobule is from the second arch. This is another concept. There are 2 books and 2 concepts, but anyway, point is, what the examiner is asking, how many hillocks? 6. Which arches involved? 1, 2. Who is forming tragus? First arch. Who is forming lobule? Second arch. These are the questions. Now, as you talk about the auricle nerve supply, there are questions on that, and if you remember, greater part of auricle is supplied by greater auricular nerve laterally as well as medially if you are talking about ear lobule. But if you are talking about the medial surface of the upper auricle, then it was a nerve from behind which is lesser occipital nerve. Do you remember that? And do you remember that the anterior auricle like tragus is supplied by auriculotemporal nerve here? Do you remember we have discussed the external auditory meatus is supplied by some vagus branch, auricular branch of vagus. Let us revise it. This is what? Yes, I told you. Near the external auditory meatus, it is the auricular branch of vagus. But remember, auricular branch of vagus cannot come here alone. Why? Because it is carried by branch of facial nerve. You are telling that facial nerve is now working like a vehicle? Yes. To carry the auricular branch of the vagus. Yes. And vagus is not coming here. How can vagus come there? Vagus is here. So how the vagus come there? Vagus is going like that. Vagus tells the facial nerve. Facial nerve, yes. Are you going there? Where? Here? Yes. Take my fibers then. You work like vehicle. So vagus nerve is giving fibers to the facial nerve so that facial nerve will become a vehicle to carry axons here. What if I cut the facial nerve? If you cut the facial nerve, then sensory loss. But facial nerve is not supplying here. Yeah, I know. But when you have cut the facial nerve, you have cut the axons of vagus nerve. That's why. Oh, you mean to say the skin around the external auditory meatus is actually supplied by vagus nerve? Yes. Facial nerve is just like a vehicle to carry the axons of the vagus nerve here? Yes. And if I cut the facial nerve, then there is sensory loss? Yes. Despite the fact that it is not supplied by facial nerve? Yes. It is actually supplied by vagus nerve. Okay. What did you tell about the other things? Other things I told you. If it is the tragus, anterior part of auricle, and also the temporal area, then it is nerve called auriculotemporal nerve. So tragus and anterior part of auricle and temporal area, then auriculotemporal nerve. Yes. What about the greater major part of auricle? Greater part of auricle, greater auricular nerve. Greater part of auricle, greater auricular nerve. lateral surface. Lateral surface. Now say greater auricular nerve supply greater part of auricle, lateral surface. Doesn't it supply medial surface? Yes, medial surface also. Medial surface also. But remember, maybe it is supplying lobule laterally and medially. But remember, it is not supplying the upper area. Why who is supplying the upper area on the medial surface? Who? Behind the occipital bone. Who? Lesser occipital nerve. Okay, lesser occipital nerve. Yes. So lesser occipital nerve supply the upper part of auricle. Yes, but only medial surface, not the lateral. Why who is supplying lateral? Lateral greater auricular nerve. And who is supplying anterior? Auricular temporal nerve. And who is supplying root? Root, you know, it is already vagus nerve. So this is the auricle nerve supply. Okay, what about the canal, auricular canal? You want to say external auditory meatus? Yes, no problem. You just remember, where was the vagus nerve supplying, you remember? Vagus nerve, I think this is the vagus nerve, auricular branch of vagus. Yes. Where is it supplying? I think around the external auditory meatus. Yes. Now remember, there is this posterior wall and floor of the external auditory meatus. Posterior wall and the floor of, see, external auditory meatus. External auditory canal. So external auditory canal you are talking about? Yes. External auditory canal has a posterior wall and the floor. So who is supplying posterior wall and the floor? Vagus, auricular branch of vagus. Then who is supplying the anterior wall and the roof? If it is anterior wall and the roof, then anterior nerve. Who? Auriculotemporal nerve. Oh, you are telling auriculotemporal nerve supply tragus anteriorly, so it is supplying the anterior wall of the external auditory canal. Yes, and also the roof. So roof and the roof and the anterior wall. Yes, and who is supplying posterior wall and floor? That is the auricular branch of vagus. See here, auricular branch of vagus. Where it is supplying? See this area. What is this area? I'm telling you, posterior wall and the floor. And what is the auriculotemporal nerve doing? Auriculotemporal nerve will supply, yes, auriculotemporal nerve will supply anterior wall and the roof of external auditory canal. That is the point. Okay, fine. What is next thing? You are telling something like this is the tympanic membrane also? Yeah, tympanic membrane also you can tell, no problem. Even tympanic membrane. So tympanic membrane, if it is posterior and floor, is supplied vagus nerve posteriorly? Yes, vagus is posterior. And if I say anterior wall and the roof, then it is supplied by the auriculotemporal nerve anteriorly? Yes, A is A, auriculotemporal is anterior. Okay, tympanic membrane also? Yes. Like external auditory canal? Yes. Outer surface of tympanic membrane? Yes, it was outer surface of tympanic membrane. So this is the inner ear now. No, not the inner ear, entire ear, but this is some description of inner ear. Where is inner ear you are showing? Petrous temporal bone. It is inside the petrous temporal bone. Where? Inside the petrous temporal bone. Let us magnify and see. This is the petrous temporal bone now. Yes. Inside that you have middle ear cavity. Yeah, middle ear cavity and inner ear also. Okay. Can we still magnify it? Yes, you magnify. As you magnify here, you will see this is the foramen magnum. Yes. That is the internal auditory meatus, where the 8th nerve, vestibulocochlear nerve, is coming towards the brain at the pontomedullary junction to enter there. Yes. This is posterior cranial fossa. You have the internal auditory meatus letting pass vestibulocochlear nerve towards the pontomedullary junction, which is in the brainstem area. Okay. What else? You know, this canals, yeah, semicircular canals, they are for the angular balance. And you know this cochlea, yeah, cochlea for hearing, cochlear nerve. And what is this utricle saccule? That is the vestibule. If the vestibule is utricle saccule, what is it for? Static and linear acceleration, static movement, statics and linear acceleration. So that is vestibule, the utricle saccule. What about the angular? Angular, you told this semicircular canals. Okay, they are inside the Petrous temporal bone, isn't it? Yes. Fine. You are telling that this is the cochlea, which is for hearing, cochlear nerve, right? And this is the semicircular canal, which is for angular balance, yes. And this is some vestibular cochlear nerve, yes. And there's some vestibule, which is utricle saccule, which is for, you told me something like static, when somebody is standing or sitting static, or maybe linear acceleration, then they are activated. Yes, linear acceleration. This is angular acceleration. So that is angular acceleration, which is for the semicircular canal. Yes. So what is happening to your writing? Writing, I am going fast. That is why writing is like that. If I go slow, angular acceleration, and if I go still slow, then it will be more beautiful. Actually, I don't have time. We are running out of time. That is a problem. Okay, then running out of time, then just go ahead. Yeah, okay. Let us look at this diagram then. What is this? This is actually, you know, what is inside? Endolymph. And what is outside? Perilymph. You have to understand that endolymph is just like CSF, so it is going to mix up with the CSF, where endolymphatic sac, which can store the endolymph and can also, you know, send it towards the CSF circulation. So we're telling that inside the semicircular canal, or maybe utricle saccule of vestibule, or maybe the, you know, cochlea, they're all filled with endolymph. Yes, it needs vibration, you know, to conduct the sound. So that endolymph is stored and then distributed by some endolymphatic sac. Yes. Where is that? That is a controversy actually, but remember, it is subdural space, subdural space. It is in the subdural space, yes, though it is controversy, but it is in the subdural space. Okay, then fine. What is the other information we want? See, this is the vestibule, which is utricle saccule. This is 2.5 turn of the cochlea. Cochlea will have 3 compartments, VMT. What is VMT? Scala vestibuli, media and tympani. What is that? This cochlea, 2.5 turns, will have VMT. What is VMT? Scala vestibuli and scala media and scala tympani. So where is scala media and tympani? That we'll be discussing, but cochlear duct is scala media. That is where you have endolymph. If you say cochlear duct is scala media, and that is where you have endolymph, then what is there in vestibuli and tympani? Perilymph. That is perilymph. Oh, in scala vestibuli and tympani of perilymph. Yes. And cochlear duct, the scala media, you have endolymph. Yes. We'll take a section and see. Okay. Then what is the next thing? Next thing we'll see. It is the middle ear cavity we have to discuss. So when we are discussing the middle ear cavity, what is there inside? Malleus incus stapes. And what else is there? See, this is the middle ear cavity, and there you have the malleus incus stapes. We want to see the boundaries of the middle ear cavity now. Boundaries, yes. Okay, let us see the boundaries then. This is malleus incus stapes, and you will find that the middle ear cavity is divided into epitympanum and mesotympanum and hypotympanum. Oh, I can understand. It means something is above epi and something is below hypo. Is that so? Yes, that is correct. Epitympanum, which is superior, mesotympanum, which is in the middle, and hypotympanum, which is inferior. So I think hypotympanum is towards the Auditory tube, yes, towards the auditory tube. And I think this malleus incus stapes are mostly in the epitympanum. Yes, malleus incus stapes are mostly in the epitympanum. These are some questions. Okay, tympanic membrane is related to mesotympanum. Yes, tympanic membrane is related to mesotympanum. That is there. Okay, what are the two muscles inside the middle ear cavity? Two muscles. One is tensor tympani to tense the tympanic membrane and dampen the sound. And the other one, stapedius to dampen the sound. So sound dampening, yes, done by two muscles in the middle ear cavity. Name. See, one of them is the tensor tympani. What is it doing? Tensing the tympanic membrane. Why? What will happen when you tense the tympanic membrane? See, if you tense the tympanic membrane, there will be less vibrations going into the inner ear. So there will be dampening of the sound. And what about the stapedius? Stapedius is attaching to stapes bone and pull the stapes from the middle ear, because stapes was knocking the middle inner ear. So stapes in the middle ear and knocking the inner ear. Why? Because it has to send a vibration inside the middle from middle to inner ear. And what if it keeps knocking? Inner ear will be damaged. So you don't want the stapes to knock too much. Yes, pull it back then. Stapedius muscle. So stapedius muscle will pull the stapes bone back, and there will be less vibration going to inner ear, prevent the damage to inner ear. It is also dampening the sound. What if stapes is not working? Hyperacusis. What if it is tensor tympani not working? Maybe again hyperacusis, because they were basically for dampening of the sound. Should not reach too much sound into the inner ear. Okay then. Can you tell me the boundaries of middle ear? Boundaries of middle ear you already know. I have told you. Roof is the tegmen tympanis, separating it from the brain cerebrum, and posteriorly it is communicating with mastoid antrum mastoid air cell, and anteriorly it is communicating with eustachian tube, the nasopharynx, and medially it is towards the inner ear cavity. There is some promontory there. Promontory. Why there is a promontory? Because some cochlea was there, cochlea. And I think stapes will hit here. Round window? No, that is oval. Okay, round window here. Yes, this is for dissipation of the sound vibration. So superior is oval window and inferior is the round window. Yes. And what is this? The facial nerve running in the facial canal in the posterior wall of the middle ear cavity. Oh yes, I remember. Let us now mark some of the relations for the middle ear cavity. And what we are doing is looking at the roof of the middle ear cavity. You see, there is this tegmen tympani, a thin piece of bone, and that is where you will see is the roof of the middle ear cavity. It is separating the middle ear cavity from the brain, that is basically cerebrum. And which part of the cerebrum will be related to the area? It is actually temporal lobe of the cerebrum. So there will be temporal lobe of the cerebrum, which is superior, and inferior will be the middle ear cavity. You will also notice some of the structures which are at the floor of the cranial cavity here. Like which one? Can you see the three canals of the middle ear, that is semicircular canals? There is one which is seen here. We call it as anterior, but it is also called as superior. So there will be one anterior, and there is one posterior, and there is one lateral semicircular canals which are in the inner ear. Actually, we can remember them as LAP. L for the lateral, A for the anterior, and P for the posterior. LAP semicircular canals. But as I'm suggesting, anterior is also called as superior because of its orientation. Now this anterior or superior semicircular canal is producing some eminence at the floor of the cranial cavity, and that is called arcuate eminence. This comes as a question, arcuate eminence. So where do you see arcuate eminence? It is at the floor of the cranial cavity. Then a question comes about the lateral semicircular canal. As we are talking about the lateral semicircular canal, you will see it will be producing some impression towards the wall of the middle ear cavity. So which wall of the middle ear cavity? Actually, first you were talking about the roof. Now you are looking at the medial wall of the middle ear cavity. So what is there in the middle wall of the middle ear cavity? That will be the lateral semicircular canal producing some eminence. We'll draw a diagram for that. It will be just above the course of the facial nerve. You see, this is the course of the facial nerve, and we have told that facial nerve is actually in the posterior wall of the middle ear cavity, but for some distance it is also running in the medial wall. Actually, it has come from the internal auditory meatus, and when it is coming from the internal auditory meatus, the facial nerve, you see, is also followed by the vestibulocochlear nerve. So it is the vestibulocochlear nerve and the facial nerve both are entering the internal auditory meatus. See, the facial nerve, when it enters the internal auditory meatus, it will take a bend, which is called as external genu of the facial nerve in the petrous part of the temporal bone. Remember, this middle ear cavity is in the petrous part of the temporal bone. So this facial nerve, as it came from the pontomedullary junction brainstem, it is going to enter the internal auditory meatus to enter the middle ear cavity and have a ganglion which is called as geniculate ganglion. It is called geniculate because it is at the bend called external genu of the facial nerve. Then you remember, facial nerve, which is in the middle ear cavity having a geniculate ganglion, after that give three branches. And it was running on the medial wall for a brief distance, and then it is running on the posterior wall of the middle ear cavity, and then exit at the stylomastoid foramen coming out of the cranial cavity. Now you will notice that when it was in the middle ear cavity, it gave a branch, and that was called as greater petrosal nerve. If you remember, this greater petrosal nerve is given after geniculate ganglion is there, and it is running at the floor of the cranial cavity. It is running towards the foramen lacerum. At the foramen lacerum, it will join. See, greater petrosal nerve is a parasympathetic nerve, and the deep petrosal nerve was sympathetic nerve. How it was given? Actually, around the internal carotid artery, we have some plexus. And what is that plexus? The T1 sympathetic plexus, and it will give the deep petrosal nerve. So the T1 sympathetic plexus around the internal carotid artery will give you deep petrosal nerve, will join with the greater petrosal nerve. Together they will form the Vidian nerve of pterygoid canal. So greater petrosal nerve is the first branch of the facial nerve in the facial canal, and is joined by the deep petrosal nerve, which is coming from the T1 sympathetic plexus around the internal carotid artery. Together they will form Vidian nerve of pterygoid canal at the floor of foramen lacerum. What is this nerve here? This is lesser petrosal nerve. It is also accompanying the greater petrosal nerve. And what about the lesser petrosal nerve? If you remember, we have discussed that the lesser petrosal nerve is supposed to carry the preganglionic fiber towards the parotid gland coming from the tympanic plexus. So where is the tympanic plexus? Tympanic plexus is actually on the medial wall of the middle ear cavity. And what is there on the medial wall of the middle ear cavity? It is the basal turn of the cochlea. If you say it is the basal turn of the cochlea, it is producing some elevation, and that elevation is called as the promontory. Now, if you're telling that the basal turn of the cochlea is producing some promontory, on the promontory you are having this plexus. What is that plexus? That will be the tympanic plexus. And who is contributing to tympanic plexus is one MCQ. If you remember, there is the tympanic branch of the glossopharyngeal nerve. And what is the tympanic branch of the glossopharyngeal nerve doing? Glossopharyngeal nerve gave a tympanic branch, and it will pass through the inferior wall of the middle ear cavity. You mean to say floor? Yes, floor. The glossopharyngeal nerve is giving a branch. Tympanic branch of glossopharyngeal is passing through the floor of the middle ear cavity to enter the middle ear cavity, forming a tympanic plexus, and that tympanic plexus is going to supply middle ear cavity, and also the eustachian tube, and also the mastoid ear cells, mastoid antrum, mastoid ear cell, and also the medial surface of tympanic membrane. Because what you're looking at, the medial wall, what is on the lateral wall of the middle ear cavity? That is tympanic membrane, and tympanic membrane on the inner surface towards the middle ear cavity will be supplied by. So what all is supplied by tympanic plexus? Middle ear cavity, and the tympanic membrane which is facing the middle ear cavity, and the eustachian tube, and the mastoid antrum, mastoid ear cell. Who is contributing to tympanic plexus? Chiefly tympanic branch of the glossopharyngeal nerve. Who else is contributing? The T1 sympathetic plexus around the internal carotid artery. There is an internal carotid plexus which is actually T1 sympathetic plexus. So T1 sympathetic plexus around the internal carotid artery, yes, that is contributing to tympanic plexus also. Yes, and tympanic plexus is also contributed by a branch from the geniculate ganglion. So branch from the geniculate ganglion. We need to know all that? Yes, because they are coming as questions. So tympanic plexus chief contribution is the 9th nerve branch, and then you have the T1 sympathetic plexus contributing, and then you have some branch from the geniculate ganglion. Yes. Okay. Where is internal carotid artery present? It is on the anterior wall of the middle ear cavity. If you say internal carotid artery is on the anterior wall of the middle ear cavity, what else is on the anterior wall related there? Is the eustachian tube, of course. And along with the eustachian tube, what is there? Actually, along with the eustachian tube is the muscle of the middle ear. Who is the muscle of middle ear? That is the tensor tympani muscle, to tense the tympanic membrane, to reduce the sound intensity, dampening of sound. So this is some tensor tympani muscle there. Yes, superior. Inferior is the eustachian tube. So these are the structures at the anterior wall. Yes. What are the structures on the medial wall? Medial wall, we have the promontory raised by the basal turn of the cochlea in the inner ear. Okay, what else? You see, there are two openings. Posterior, you see, this is posterior superior and posterior inferior. What is posterior superior? Posterior superior, you can see the oval window. And what about the other window? There is a round window also. Where is the round window? It will be here. So you're telling that there is some posterior superior, the oval window. Yes, and posterior inferior, the round window. What is this for? Actually, what you see is that there is sound coming, and it is vibrating tympanic membrane, and it is vibrating the malleus incus stapes, and stapes is now knocking on the inner ear. How? The footplate of stapes will be fixed to the oval window, and as it is vibrating, it will vibrate the perilymph inside the inner ear. Now that perilymph which is vibrating inside the inner ear is in a column, a long column. What is that? There will be some ducts inside that perilymph is there, and it is called as scala vestibuli. So it will be some perilymph in the scala vestibuli. Yes, and then scala vestibuli is continuous with the scala tympani. Where is all this? In the inner ear. Okay, in the inner ear you have scala vestibuli, which is communicating with the oval window. Then what is it continuing as? Scala tympani, and which is then continuing as it will be communicating towards the round window. This will be more clear when you see the inner ear detail. But the thing is, on the medial wall of the middle ear, you have the oval window and the round window. Oval window is covered by the footplate of stapes, and the round window is covered by a tympanic membrane. It is called secondary tympanic membrane. So there is some secondary tympanic membrane covering the round window on the medial wall of the middle ear cavity. Yes. What else is there on the medial wall? I told you. there will be the slight course of the facial nerve, and above that some raised elevation produced by lateral semicircular canal. Then what is on the posterior side? Posterior side, there will be an opening towards the mastoid ear cells. Which is mastoid antrum? Yes, it is called additus. There will be additus, which is the communication of the middle ear cavity with the mastoid ear antrum. And what else on the posterior side? This is facial nerve running in the facial canal on the posterior wall of the middle ear cavity. And what else? There is one elevation which we see here, and it will be called as the pyramid. And what is the importance of pyramid? On the pyramid, you will have the tendon of stapedius muscle attaching. So tendon of the stapedius muscle attached to the pyramid, and that is what is stapedius doing? Stapedius is a muscle which will be pulling the stapes bone posteriorly. Why it will pull the stapes bone posteriorly? So that it will not continuously knock on the inner ear. You mean to say it is some reflex, stapedial reflex? Yes, stapedial reflex, pulling the stapedius muscle posteriorly to prevent damage to the inner ear by preventing continuous knocking on the inner ear. So these are the things on the posterior side. What is on the lateral wall of the middle ear cavity? That we have removed. Yeah, what you have removed? The tympanic membrane. So tympanic membrane you have removed. Then what is at the floor? Floor we have seen the branch of the ninth nerve coming. Yeah, what else? It is this internal jugular vein. What is internal jugular vein doing here? Do you remember it is a continuation of what? You remember that is continuation of the sigmoid sinus. This is the marking of sigmoid sinus. So that is the marking. You mean to say sigmoid sinus is continuing as the internal jugular vein will be at the floor of the middle ear cavity? Yes, floor of the middle ear cavity. That is internal jugular vein. And if you say this is internal jugular vein, then this is the ghost of the sigmoid sinus. There is a ghosted sigmoid sinus shown there. Now, if you have all that information with you, then you can draw a simplified diagram. And in the simplified diagram, what we will see, just draw it and then we'll discuss. So as you're drawing the middle ear cavity, you'll find middle cavity is having a roof and anterior wall, and it is also having a floor. So you're telling that it is having a floor there? Yes. And what else? There is a posterior wall also. So there is a roof. This is the roof. Yes. And that is the posterior wall. Yes. This is the anterior wall. Yes. Anterior wall, posterior wall. That is the roof. And there's a floor also. And what else is there? Actually, we have opened the door. Door, you have opened which door? The lateral wall we have opened. So you have opened the lateral wall. Yes. What is lateral wall? Lateral wall is actually tympanic membrane. So it's kind of a door opened like that. Yes, to see inside the middle ear cavity. And the lateral wall which we have opened from here to there is having tympanic membrane. If you're telling that this is the tympanic membrane, I think on the tympanic membrane is running some nerve. Yes, that nerve is running. It is a branch of the facial nerve running on the posterior wall of the middle ear cavity. What branch of facial nerve? That is cauda tympani nerve. So this is cauda tympani nerve, which is a branch of the facial nerve, and it is running with the inner surface of tympanic membrane towards the middle ear cavity. Yes, and it is a branch of facial nerve. And where is facial nerve? Facial nerve, we have told, is running in the facial canal before it is exiting at the stylomastoid foramen. So before exiting at the stylomastoid foramen, it was facial nerve. Yes, facial nerve running in the posterior wall of the middle ear cavity. Yes, but it was also running on the medial wall for some time. And what was above the medial wall course? Above that there was a prominence, and that prominence was due to the lateral semicircular canal. So you mean to say lateral semicircular canal is producing some eminence towards the Middle ear cavity? Yes, on the medial wall. This is medial wall. What else is there on the medial wall? Actually, on the medial wall, we have the promontory. So, what is this promontory due to? The basal turn of the cochlea. So, there is some basal turn of the cochlea in the inner ear. Yes, but it is producing some impression in the middle ear. So this is the medial wall of the middle ear cavity. Yes, which is having some promontory elevation, right? And what else on the medial wall? There is the short course of the facial nerve. And what is above that? It is the impression of the lateral semicircular canal. What else is there? You have known that there was some opening here, oval, and here round. So you mean to say round window and the oval window. This is oval window. Yes, that is oval window on the medial wall of the middle ear cavity. This is round window. And what else do you see on the medial wall? It's a tympanic plexus. If you say it is the tympanic plexus, then who is forming the tympanic plexus? This nerve coming from the floor. Which nerve is coming from the floor? Tympanic branch of the glossopharyngeal nerve. So now you're telling that there is some tympanic branch of the glossopharyngeal nerve which is entering the middle ear cavity through the floor. Yes, through the floor. At the floor, I have one more structure, and that structure is called as the internal jugular vein. So there is internal jugular vein at the floor, and there is also this tympanic branch of the glossopharyngeal nerve. What is it doing? It is contributing to the tympanic plexus, and where it is? It is present on the promontory. Who else is contributing to tympanic plexus? It is actually one ganglion. It is, the one ganglion of facial nerve. What is that ganglion of facial nerve? Geniculate ganglion. So, geniculate ganglion of facial nerve in the middle ear cavity. Yes, in the middle ear cavity. And it is contributing to the tympanic plexus, right? Yeah, I think it is contributed by some other thing also. What is that? You know, there is one artery where anterior to the anterior wall of the middle ear cavity. So there is some artery related to the anterior wall of the middle ear cavity. I think it is surrounded by some T1 sympathetic plexus. Yes, it is surrounded by some T1 sympathetic plexus, and that's also is contributing to the tympanic plexus. So internal carotid artery is anterior relation of the middle ear cavity. What else is there in the anterior relation of the middle ear cavity? There was a tube. What tube? Actually, there are two openings, and upper opening is for the muscle which is called tensor tympani muscle, and lower opening. Lower opening is for the tube which is called eustachian tube. So telling that anterior wall of middle ear cavity has two structures related. The upper opening for tensor tympani muscle which will tense the tympanic membrane there. Yes, to dampen the sound, and eustachian tube which is bringing air to the middle ear cavity from the nasopharynx. Yes, that is the eustachian tube anteriorly. And as you see, what is the other thing at the posterior wall? If you have told that it was some facial nerve running the facial canal in the posterior wall of the middle ear cavity, what else? Actually, there is an opening towards the mastoid antrum. And what is that opening towards the mastoid antrum? That is called as additus to the mastoid antrum. So you have some opening additus towards the mastoid antrum posteriorly on the posterior wall of the middle ear cavity. Yes, it is there. There is one projection also on the posterior wall of the middle ear cavity that is called pyramid, and attaching to pyramid is the stapedius muscle there. So there will be stapedius muscle which will pull the stapes posteriorly then. Yes, actually on the pyramid, on the posterior wall of the middle ear cavity, you have attachment to the stapedius tendon, and stapedius is pulling the stapes bone posteriorly to prevent the continuous knocking of stapes foot plate on the round window towards the scala vestibuli, the perilymph. With all that information, we can proceed further now. And this is the middle ear cavity having the malleus bone and incus bone and the stapes bone. So you are telling this is malleus bone which is attaching tympanic membrane? Yes. And this is incus and the stapes. Where is stapes present? Actually, middle ear cavity is divided into three parts. There is a mesotympanum, middle, and above that epitympanum, and below that is the hypotympanum. So which is the narrowest dimension. If you say narrowest dimension, that came as a question, and you can remember that this is the narrowest dimension. It is actually around 2 millimeter. What is 2 millimeter? The distance of the tympanic membrane and the medial wall of the middle ear cavity. So tympanic membrane, which is the lateral wall of the middle ear cavity, yes, and then there's a medial wall of the middle ear cavity where you have some oval window and attachment of the footplate of stapes. Yes, actually remember the dimensions of the lateral wall of the middle ear cavity and the medial wall of middle ear cavity is 2 millimeter here at the mesotympanum. What does it contain? It contains the stapes bone and the pars tensa of the tympanic membrane. So tympanic membrane is in the relation of the mesotympanum. Yes, where is malleus incus? Malleus incus is most majorly in the epitympanum, which is the largest dimension. If it is the largest dimension, then which is how much is that? That will be around 6 millimeter. So you're telling that this will be around 6 millimeter. Yes, that is around 6 millimeter. And what about the hypotympanum? It is 4 millimeter. So this is 4 millimeter. Yes. So you are trying to say that the shortest distance is in the mesotympanum between the medial wall and lateral wall of middle ear cavity. Yes, that is 2 millimeter. And then you have to look at this area again. How? See, you are going to magnify the middle ear cavity now and looking from the same view, the anterior view. So we are looking at the anterior view, same view which we just saw. Yes, and magnifying. Yes. Why are we magnifying? To see the bones. Which bones? Malleus, incus, and stapes. Okay, let us see them. As you magnify, you see this is the malleus, the most lateral bone. This is incus, and stapes, which is most medial bone. We have put a fiber optic illumination where in the external ear canal and one fiber optic instruments in the middle ear cavity. So this is the middle ear cavity now. You are inside. Yes. What do you see in the middle ear cavity? See, this is the malleus bone which will be attaching to the tympanic membrane, and this is the stapes bone which will be attaching to the medial wall of the middle ear cavity. If you say stapes will be attaching to medial wall of the middle ear cavity, can we just magnify this? What is this? Yeah, you see here. Can see this is the, yes, stapes footplate. And what is stapes footplate doing? What do you think it is doing? Attaching to the oval window. Medial wall of the middle ear cavity. Yes. What is attaching laterally? You see here, this is tympanic membrane laterally, and what is attaching to that is the malleus. So malleus attaching to tympanic membrane laterally. Lateral wall of the middle ear cavity. Yes. Okay. What else do you want to see? Let me just make this diagram schematic, because maybe it is not very clearly seen to you, but we'll make it schematic. So what we'll find, this is what we are discussing. See, this is the malleus bone attaching where? To the tympanic membrane. Where is tympanic membrane? To the lateral wall of the middle ear cavity. If this is the lateral wall of middle ear cavity, the malleus is attaching here. I think most of the malleus and incus are in the epitympanum. Yes, they are in the epitympanum. Where is stapes? Stapes is here, and it is in the mesotympanum. And what is it pulled by? It is being pulled by this tendon. You see, that is the stapedius muscle attaching to pyramid on the posterior wall of the middle ear cavity. So this is the pyramid on the posterior wall of the middle ear cavity attaching some stapedius muscle attaching to the stapes bone there. Yes. And who is this muscle coming from anterior side? This muscle which is coming from the anterior side is of course the tensor tympani. And what is it doing? It will tense the tympanic membrane. That is what it is doing. So this muscle came from anterior side. Yes. And what is this? This must be the round window. If this is the round window, that is the oval window, then both of them are on the medial wall of the middle ear cavity. Yes, they are. They are. So this orientation, you can see anteriorly when the muscle was found, the tensor tympani, it is the eustachian tube running inferiorly. So inferiorly is eustachian tube and superiorly is the tensor tympani, but both are on the anterior wall of the middle ear cavity there. Now, as we are going to talk about the inner ear is actually having labyrinth. Now, if you say it is having labyrinth, what labyrinth it is having? It is having one outer, yes, bony labyrinth, and there is one inner, yes, the membranous labyrinth. So outer is bony and inner is membranous, yes. Right. What do you include there? Let us see. This is the inner ear we have to magnify now. And when you magnify, what you'll find? There is a bony labyrinth. What is included? The cochlea, and then in the middle we have the vestibule, and what is posteriorly is the semicircular canal. So semicircular canal are posterior, in the middle is the vestibule, and anteriorly we have the cochlea. This is the inner ear. Let us magnify. So as you're magnifying the inner ear, you will find, as you magnify the contents of the inner ear, you'll find there is an outer bony labyrinth, and inner blue color is the membranous labyrinth. Actually, the arrangement is such that outside is bone, and then what is inside? Perilymph, and what is inside? Membranous labyrinth, and what is inside? Endolymph. Let us make a diagram for that. But understand that outer is bony labyrinth and inside is membranous labyrinth. What is between the two? Perilymph. And what is inside the membranous labyrinth? Endolymph. Endolymph. You will also see that there is the cochlea. How many turns the cochlea has? Cochlea is having around 2.75 turns. What is 2.75 turns? More than 2.5 actually. So more than 2.5 turn, 2.75 turn. Yes, more than 2.5, 2.5. Reaching three turns. Okay, then what else? You have to understand that it is a basal turn and it is a apical turn. So what about that? Basal turn will be receiving the high frequency sound, and apical the low frequency sound. So there you detect the low frequency sound. Yes, cochlea for hearing, cochlear nerve. Yeah, cochlear nerve for hearing, cochlear spiral organ. So spiral organ of cochlea, spiral ganglion. Yes, spiral ganglion is cochlear ganglion because it is spirally present, so spiral ganglion. Okay, what else is this? This is the vestibule. And what is in the vestibule? There are membranous labyrinth. What's membranous labyrinth is there? We'll discuss the two parts. There'll be utricle and saccule. Now, if you say in the vestibule you have membranous, utricle, saccule, where is the saccule connecting? Saccule will be connecting with the cochlear duct. And where is the utricle connecting? Utricle will be connecting with the semicircular canal. As the semicircular canal are 3 in number, the 3 semicircular canal will be communicating with the what? Utricle part of vestibule, which is membranous labyrinth. Can we see some more details of all that? Yes, let us do one thing. First, you have to understand that there is, yes, outer bony labyrinth. Yes, outer bony labyrinth. Then inside is the membranous labyrinth. So inside is the membranous labyrinth, right? Then between the outer bony and the inner membranous labyrinth, you have some fluid. And what is that fluid? That fluid which is between the bony and membranous labyrinth is called as perilymph. If you say this is perilymph, then where is endolymph? Endolymph must be inside here. This is endolymph. So that will be endolymph inside the membranous labyrinth. Yes. What is this endolymph, perilymph? Lymph. You know what is lymph? Lymph is ultrafiltrate of blood. So this is ultrafiltrate of blood. Where will it be found by? Of course, capillary plexus. And where that will be found by? Of course, capillary plexus. And where it will be draining into some other plexus, venous plexus. Okay, so capillary plexus will form and venous plexus will absorb it. Yes. Okay, what is the other detail? Other detail is you have to look at the bony labyrinth various component. What are the various component of bony labyrinth then? See, I have told you there's a cochlea with the 2.75 turn, and there is a vestibule there, and the semicircular canal, which are 3 in number. So this is what is called bony labyrinth. Yes, 3 things. What are the 3 things? There is a cochlea, and there's a vestibule, And so there is one cochlea, there is one vestibule, and there is semicircular canals. Yes, three things are there in the bony labyrinth. And what is this opening in the vestibule? Oval window. And what is this opening? That is the round window. And this is which part of the ear? Inner ear. This is the inner ear. Okay, fine. What is the next detail? Actually, we have told that bony labyrinth, inside that is membranous labyrinth. Yeah, so inside the cochlea, when you say membranous labyrinth, it is a cochlear duct. There's a cochlear duct now? Yes. Okay, then what is inside the vestibule? I told you, utricle and saccule. And where is the saccule communicating with? If you say saccule, then it must be communicating with the cochlear duct. And where is the utricle communicating with? It is communicating with the semicircular canal. So in the vestibule, there are two things. One is utricle and saccule. The saccule communicate with the cochlear duct. And what is the utricle communicating with? Semicircular canal. And the semicircular canal is bony labyrinth. What is the membranous labyrinth? That is the semicircular ducts. Semicircular ducts. Can you tell me the function of what? Inner ear. Yes. Inner ear will give us the nerve which is called vestibulocochlear nerve. So vestibular for balance, equilibrium. And what is cochlear for? Cochlear for hearing. What do you include in the vestibular apparatus? Vestibular apparatus is vestibule, of course. And who else? The semicircular canals. So you are telling the three things here now. Yes, if it is cochlear duct, it is for hearing. Hearing is cochlea. Cochlear nerve will be there. And where the vestibular nerve will come from? Vestibular nerve is for balance and it will come from the vestibule there. And what is this semicircular canal for? Actually, if you are static or you are having linear acceleration, so static or linear acceleration, deceleration, yes, then it is basically the vestibule component. And what if I am having a round movement, angular acceleration, then semicircular canal. So semicircular canal for angular acceleration. What about the linear? Linear is the vestibule. Can we discuss it again? Let's do that. Understand that when we are talking about the membranous labyrinth, it has two parts. What are the two parts? There will be membranous labyrinth which is filled with endolymph and it is surrounded by perilymph. Okay, what else? See, it is cochlear duct for hearing, cochlear nerve, and vestibular nerve for vestibular nerve is for equilibrium, balance. And what is under the vestibular system? It is the semicircular canal which is for angular rotation. And what is the vestibule for? Vestibule has two things, utricle saccule, and that utricle saccule is for static equilibrium or linear acceleration, deceleration. Now, once you have that orientation, we can move further and talk about the membranous labyrinth. So, what did you see? Some ducts were there. What ducts were there? See, cochlea is having the cochlear duct. And what is the vestibule having? Vestibule is having utricle and saccule. Yes, utricle and saccule. I think saccule is communicating with cochlear duct. Yes, correct. Saccule is this. And it is now communicating with the cochlear duct. What is this communication called? What is that communication called? It is called as ductus reunion. Ductus reunion. So when the membranous labyrinth, cochlear duct, is communicating with the membranous labyrinth, the saccule, there is some ductus reunion. This will be the location of the ductus reunion. Yes, but I see there is some ductus endolymphaticus also. Yes, that is ductus endolymphaticus and endolymphatic sac also. This is communicating utricle with saccule. So utricle is now communicating with saccule, and this is utricle saccule communication there. Yes, and continuing as the duct and sac. Where is the sac present? Actually, that is a lot of controversy. What is the controversy? Some books will say that the endolymphatic sac is present related to dura mater layers, but they don't exactly say that where exactly it is present, because some books will say subdural. So you believe subdural or not? I believe that it is subdural, but then some books will say it is intradural. So do you believe that? Yeah, sometime I believe that, and some will say it is extradural. Oh, so it is not clear that where it is? No. So what do you give the first answer? First answer, I'll say it is under dura mater, subdural. And if not found, then I'll say intradural. Within the two layers of dura mater. You know the two layers of dura mater? Endosteal and the meningeal layer. So it can be intradural also? Yes. And it can be extradural also? Yeah. Why would you say it is extradural? Actually, the thing is, it is mentioned endolymph, which is inside. The endolymphatic sac is draining into some it is basically vessels making a plexus. You mean to say extradural plexus of vessels? Yes, it drains there. Are you trying to say endolymph is draining into the vascular plexus, which is extradural vascular plexus? Yes. So that is quite a controversy. What is the first answer? Somebody is asking me, where is the ductus endolymphaticus present? Finally, so it should be subdural. If not found, then it is intradural. If not found, then it is extradural. So three answers in a sequence. Yes. Okay. What is this semicircular duct doing? Semicircular duct, you remember, they were membranous labyrinth within the semicircular canal. Yeah, I remember something. Lap, you told lap. Yes, lap. There is a lateral which is producing some elevation on the middle ear cavity. There is one anterior which is also called as superior, producing some arcuate eminence at the floor of the cranial cavity. And then there is one posterior which is called posterior because it is towards the posterior side. How do they communicate with the utricle? You told it they are communicating with the utricle. Yes, by 5 openings. And what are the 5 openings? They are called as the 5 ampulla. And what is inside the 5 ampulla? But there are 3 canals. Yeah, there are 3 canals, but the opening are 5. So I see 1, 2 and 3 only. Yeah, from here you can see 3, but they're total 5. This is already a question. All of this, whatever we are discussing, everything, each line is one MCQ. Whatever we have discussed till now. So you are telling that this is 3 semicircular canals. Yes. And they are now opening into the utricle with 5 dilated structures called ampulla. What is in the ampulla? Crista ampullaris. And what is crista ampullaris? Crista ampullaris is the receptor for angular rotation. So if you want to detect the angular rotation, you will detect by crista ampullaris, which is in the semicircular canals. And how do I detect the linear acceleration or static balance? That is called as the macula. And where is macula, the receptor? The macula receptor will be in the vestibule, where in the utricle and saccule. So macula is here and here. Yes, actually macula is the receptor for static balance, and that will be in the utricle and saccule, means vestibule, bony vestibule. Yeah, bony vestibule, but membranous is utricle, saccule. They will have the macula. Macula is the receptor for static balance. And what is the crista ampullaris? In the ampulla of the semicircular canal, that is for angular balance. This is some information we needed. Now, as you see, we have separated the membranous labyrinth, and you can see one swelling here, one here, and one here, and one here, and one here, or total 5. Yes, where are they communicating? With the utricle. So utricle will have 5 openings now. Yes, from the semicircular canal. Yes, and what the saccule will be having? Saccule has a communication here. What is that communication called? You remember, that is called ductus reunions. So ductus reunions, where you have the reunion going on. Yes, it is actually cochlear duct with the saccule. And what is the duct between the two? Which two? These two? These two, that was actually endolymphatic duct and endolymphatic sac. So it is the endolymphatic duct, endolymphatic sac. But what is this? This is called utricle saccule duct. So utricle saccule duct. Yes. So you mean to say everything is connected? Yeah, everything is connected. Everything is filled by endolymph. And where is endolymph absorbed? Into the extradural vascular plexus. So it is drained into extradural vascular plexus, the endolymph. Now there is again a controversy, but we don't want to go still deeper than this. So this much should suffice our need. So as we have learned that inside the cochlea you have cochlear duct. Inside the vestibule we have utricle saccule, and inside the semicircular canal you have semicircular duct. This is membranous labyrinth, all filled with endolymph. Then you are going to talk about the sound conduction, how the sound conduction is happening. In fact, sound is vibrations in the air. And what are the vibrations doing? Those vibrations in the air will enter the external ear canal and vibrate the tympanic membrane, which will then vibrate the ossicles, which will then vibrate the perilymph in the inner ear. How will you vibrate the perilymph in the inner ear? You see, the sound waves have come, they are vibrating the tympanic membrane, vibrating malleus, incus and stapes, which are vibrating the perilymph. Where is perilymph? It is in the scala vestibuli. So there is a scala vestibuli in the cochlea. Yes, cochlea, hearing. Hearing is cochlea. And now as the scala vestibuli is receiving the vibrations, those vibrations will be traveling through the scala vestibuli and going to the tip, which is called helicotrema. At the helicotrema, they will be continuous with the other channel, which is called scala tympani. So now it is coming to this scala tympani. Yes, you mean to say superiorly what you see is scala vestibuli. Yes, and then it is at the tip, which is helicotrema. Now it is continuous with the scala tympani, which is inferior. Yes, and where is that vibration coming? The vibration will keep vibrating the fluid perilymph. Yeah, perilymph. Then it will be dissipating that vibration at the round window. Round window covered by secondary tympanic membrane. Yes, that is a secondary tympanic membrane which will be helping us to dissipate those kind of vibration. And which window was sending the vibration inside? That is of course the oval window, stapes footplate oval window. What is this green color, blue color? That is the actual cochlear duct. So this is the cochlear duct or membranous labyrinth. Yes, this is the membranous labyrinth, and that is the cochlear duct. So this is going to be the cochlear duct, which is scala media. There you will find scala media. Actually, there are three things. VMT. What is VMT? If you look at the upper, it is scala vestibuli. And if you look at the lower, it was scala tympani. And what was in the middle? It was scala media. The actual cochlear duct. You mean to say that is the one which is filled with endolymph? Yes, that is the one which is filled with endolymph, because these two are filled with perilymph. So you're telling that scala vestibuli and tympani are filled with perilymph. Yes. And the scala media is filled with endolymph. Yes. This blue color will be the endolymph, and that is where you have the hair cells. Hair cells for detecting the vibration and giving it to this nerve. Which nerve? The cochlear nerve. So this is the cochlear nerve which is receiving the hearing. Yes. Actually, it is a transducer where in the organ of Corti. So there is some organ of Corti in the cochlear duct area. Yes, and that organ of Corti is a transducer. It will change it'll be changing that organ of Corti in the cochlear duct will be a transducer and changing the vibration, mechanical energy into electrical energy, and that will become electrical energy in the form of impulse, which is going towards the brain to detect the sound activity. So let us draw the diagram in a simplified way. Actually, there is the footplate of stapes, and where is it knocking? It is knocking into what is called as the oval window. And what is oval window continuous with? Oval window is continuous with the scala vestibuli, and which is then continuous with the, if this is a scala vestibuli, then it is helicotrema, and after the helicotrema, the bend, it will be continuous with the scala tympani. And what the vibration of scala tympani will be dissipated by? It will be dissipated by a secondary tympanic membrane, and that is secondary tympanic membrane on the round window. So on the round window, you have some secondary tympanic membrane to dissipate the vibration which were given here like this. Yes. What is moving with that? The perilymph. If you say this is perilymph, then I think there is one more thing, scala media. Yes, there is a scala media here. And when you're talking about the scala media, you'll find it is filled with endolymph. And that is where you will see the organ of Corti. So we'll be talking about organ of Corti now. Yes, we'll be talking about that, because from there will come the nerve, which is called cochlear nerve, which will actually bring the auditory information. And one more thing, you have to understand that this perilymph, which is ultra filtrate of blood filling the scala vestibuli and scala tympani, is absorbed by, yes, where it is absorbed into the CSF space. You mean to the subarachnoid space? Yes, subarachnoid space. Actually, it is continuous with the subarachnoid space. So this perilymph in the bony labyrinth, yes, is draining into CSF space. Yes, that is what you have to remember. And then you move further. You are looking at the organ of Corti. Organ of Corti is having some cells, and they are hair cells. And hair cells will have something called as stereocilia. And as the stereocilia are moving, they will be some, it is mechanical movement which is converted into electrical stimuli, and it is working like transducer. So you have some transducers to convert mechanical energy into electrical energy. Yes, that is what we are going to talk about. But these hair cells are two types. There will be inner and outer. So what about the inner and outer? Actually, inner cells are basically for the actual sound production. And what is the outer cell for? Outer cell are modulatory. Modulatory means they are actually modulating the activity of the inner cell. So you are telling that inner cell was basically conducting the sound, yes, and you want to modulate that, yes, and you have some outer cell for modulation, right? If you're talking about the cochlear nerve, you will see, which is carrying the sound, it receives 95% of the innervation from inner cell. So cochlear nerve carry 95% of innervation of inner cell. Then how much the outer cell contribute? Outer cell is basically not for sound conduction. It is just for sound modulation. Yeah, but how much of innervation? You can see maybe 5 to 10%. So 5 to 10% is outer cell. Yes. And majorly it is the inner cell which is sending the axons in cochlear nerve. Yes, cochlear nerve is basically the axons of inner cell. And outer cell is only 5%, 10% contribution. Yes, this you have to remember. We are magnifying the area of the cochlea. As you magnify the area of cochlea, because this is all about organ of Corti, which is inside the cochlea, let us do that. So as you magnify the cochlea, you will see there were three chambers. What were the three chambers? Actually, there was a scala vestibuli, scala media, and scala tympani. Oh yes, okay. There is a scala vestibuli, scala media, and scala tympani. You mean to say scala vestibuli, tympani filled with perilymph, and scala media filled with endolymph. That is the story? Yes, actually there is an outer bony labyrinth, and this blue color is membranous labyrinth. So outer is bony labyrinth, blue color is membranous labyrinth. In the membranous labyrinth, you have between the bony and membranous labyrinth, yes, actually this will be filled with perilymph, and that will be filled with endolymph. What else? You have to magnify this again. So as you're magnifying this again, what do you want there? What you have to understand is there will be stria vascularis here. And what is the function of stria vascularis here? Stria vascularis is secreting endolymph inside the cochlear duct, which is also called scala media. So you are telling there is some stria vascularis. Yes, stria vascularis is some capillary plexus there. So stria vascularis, some capillary plexus here, which is secreting endolymph in the cochlear duct. Yes, that is scala media there. And what is that endolymph doing? Endolymph is also receiving some vibrations and will be moving the tectorial membrane. And what will happen when tectorial membrane is moved? Then it will be the hair cells which are stimulated. Where is hair cell? In the organ of Corti. What is about organ of Corti? Can we magnify this? I will magnify. But first you tell, this is the scala vestibuli. Yes, this is the vestibular membrane. Vestibular membrane, you mean to say Reissner's membrane? Yes, you can say vestibular, or it has one more name, Reissner, Reissner's membrane. So this is the vestibular membrane or the Reissner's membrane. Yes. Then there is one basilar membrane here at the base. So this is the basilar membrane. There are three membranes. Yes, there is a basilar membrane which is separating scala media from the scala tympani. So you're telling that if I want to separate scala vestibuli from the scala media, I have the vestibular membrane or the Reissner's membrane? Yes. And if I want to separate the scala media from the scala tympani, I have the basilar membrane there. Yes, that is the basilar membrane. Then what is the tectoral membrane? It is inside the scala media. And what is tectoral membrane doing? Let us see what is it doing. You have to magnify the organ of Corti now. So as you magnify the organ of Corti, what do we see there? What we see there is this. What is this? This is the rods of the organ of the Corti. If these are the rods of the organ of the Corti, then what is the importance of organ of Corti? Actually, there you saw the hair cells. So these are the hair cells. Yes, these are the hair cells, and they are having outer hair cell, and which is very less, 5 to 10% population innervating the cochlear nerve. This is the nerve fiber, cochlear nerve. So who is 90 to 95%? That will be inner hair cell. So you're telling that it is inner hair cell which is the chief contributor to these axons. Yes, 95%. And outer hair cell is just for modulatory function, which is around 5 to 10%. Yes, 5 to 10%. So outer cell is giving 5 to 10% of the axons of the cochlear nerve. Yes, axons of the cochlear nerve for hearing, because cochlear nerve, most of the axons come from inner hair cell. If inner hair cell is involved in hearing, then what is outer hair cell for? It is just for modulation of the sound. So whatever sound is being produced, it is modulatory. Yes. Okay, so we don't need it much. No. What is more important is this one. But there are some other cells also into play. So what are the other cells into play? Can you see the basilar membrane here? On that is the organ of Corti. Yeah. And then you can see the tectoral membrane. So there will be some endolymph here which is moving. So when the endolymph is moving, what is moving? This tectoral membrane is moving. So it will be in touch with the stereocilia. So these are the stereocilia of the hair cell. Yes. And when the stereocilia are deviated, then some mechanical energy is being converted into the electrical energy. It is working like a transducer, and that will be detected by brain as sound. So this is what we were talking about. Yes. Now the examiner has given recently one histological picture of the same, and you have to identify the same thing. They give you something like what is this A, what is this B, what is this C, what is this D. So you should be careful about the histological picture, like this tectoral membrane they are showing here. So that is tectoral membrane. Who is this? That is the Reissner's membrane, the vestibular membrane. Then where is the basilar membrane? That is here. What is on the basilar membrane? There is the inner hair cell giving 95% of the cochlear nerve fiber. And what is the outer cell doing? Outer cell will give 5 to 10%. So let us magnify it. See, this is outer cell here, and they will be shown here. This is inner cell, so they'll be shown here. And this is the tunnel of Corti, and then you have the basilar membrane, and then you have the tectoral membrane here. This is the tectoral membrane. Let us magnify it. So as you're magnifying it, what is this? Above this, this is the cochlear duct scala media filled with what is called as the endolymph. And what is it separated from the scala vestibuli by? Scala vestibuli is there, so it is separated by vestibular membrane, or what is called Reissner's membrane. So this scala vestibuli, the scala media. Yes. What is in the scala media is the tectoral membrane, which is moving, and is this is, you can see here, hair cells of the organ of Corti. So what is it doing? It will have some stereocilia, and those stereocilia are deformed, and some mechanical energy into electrical energy carried by this nerve. What is this nerve? The cochlear nerve. Why the ganglion of the cochlear nerve called spiral ganglion? Because cochlea spiral, spiral ganglion, or spiral ganglion. Okay, spirally present. Yes. Okay. So this is the basilar membrane here. I think it is going to separate the scala tympani from the scala media. Yes, that is what it is doing. So this is scala media here, this is scala tympani, and separating the two is a basilar membrane. Yes, that is what. So this is how we identify. Where is the organ of Corti rods? If you want to see the rods of the organ of Corti, then they are here. Rods of the organ of Corti, and outer hair cell and inner hair cell. Okay. Can we draw this quickly? Yes, you can draw quickly. You tell this is the bony labyrinth, and then there will be membranous also. Yeah, okay, membranous labyrinth, bony labyrinth, right. This is bony, yes. Inside is membranous, yes. Right. What is there? You will see some membranes. What membranes? You will see there is one membrane here and there is one membrane here. I think there is one more. Yeah, there is one more, but first you tell. This is scala vestibuli, and this is scala media, and this is scala tympani. So you're telling that it is a scala vestibuli which has perilymph, yes, and scala tympani which is having perilymph, yes, and here you have the endolymph, yes, secreted by some stria vascularis, yes. This is the stria vascularis which is going to secrete the endolymph. Now, if this is the stria vascularis which is secreting endolymph which is inside the scala media, I think scala media is the area which you call as the cochlear duct. Yes, that is called as the cochlear duct. It is inside the cochlea. So, cochlear duct, the membranous labyrinth. And what is this membrane? This membrane is called as the vestibular membrane, separating the scala vestibuli. What is the other name of vestibular membrane? It is also called Reisner's membrane. If that is the Reisner's membrane, then this must be the basilar membrane. Yes, that is the basilar membrane. If you say this is the basilar membrane, there is a tectorial membrane also. Yes, but first for the basilar membrane, you show that this is the organ of Corti. If that is the organ of Corti, there are two rods of the organ of Corti. Yes, and then you will tell that there are some cells. There is inner hair cell with serosilia, and there is some outer hair cell with serosilia. So outer hair cell, yes, inner hair cell, yes, and it is the inner hair cell which is giving 95% of the axons to make the spiral ganglion, and spiral ganglion is basically cochlear ganglion, and it is having bipolar neurons. Bipolar means one process here, one process there. Yes, one process here, one process there. The cochlear ganglion or spiral ganglion, the spiral ganglion is bipolar neuron, and it is having, two processes. One is towards the organ of Corti, and where is the other one? Other one is towards the CNS. So can we follow it towards the CNS then? The auditory pathway? Yes, we'll discuss the auditory pathway then. But first you tell this is the tectorial membrane. The tectorial membrane like this, yes, that is the tectorial membrane, because the shearing effect or the deformation of the tectorial membrane is going to deform the serosilia, and that mechanical energy converted into electrical energy, which is detected as a sound by the inner ear. So that was the orientation. Now, auditory pathway, as we are carrying this cochlear nerve, where is it going? Do you remember where is it going? Superior temporal gyrus, Haschel's gyrus. Can you tell me which part of the internal capsule it is using? Auditory pathway, music pathway. See, this is the cochlea and spiral ganglion and the cochlear nerve and pontomedullary junction and inferior colliculus. And between the two is lateral lemniscus. What is lemniscus? Bundle of axons, lateral lemniscus. And what is from the inferior colliculus? It is towards the medial deniculate body, medial for music. And then tell me, which fibers of internal capsule? This is the cochlea, giving the cochlear nerve, entering the brainstem at pontomedullary junction, and then sending some lateral lemniscus towards the inferior colliculus of the midbrain, and then the medial deniculate body, metathalamus, and then which fibers? They were under the lentiform, retro or sublentiform. Sublentiform. Sublentiform fibers of the internal capsule and going towards the Haschel gyrus, which is area number 4142. This is what we are supposed to discuss now. It is the superior temporal gyrus there, Haschel's gyrus. So this is the pathway which we are supposed to discuss. Yes, let us do it. I'll give you a mnemonic. The mnemonic is SLIM 4142. What kind of mnemonic is this, SLIM 4142? What is S for? S is for superior olivary nucleus in the medulla oblongata. And what is L for? Lateral lemniscus. And what is I for? Inferior colliculus. And what is M for? Medial genital body. Yes, okay, SLIM, right. So S is for superior olivary nucleus, L is for lateral lemniscus, I is for inferior colliculus, M for medial genital body, and what is it? Okay, 4142, superior temporal gyrus. Yes, let's do that. So this was the cochlea. Yes. And it is giving cochlear nerve. Yes, cochlear nerve. And the cochlear nerve, what is it doing? Cochlear nerve, it is carrying the sound information. Yes, but what is it doing after that? After that, you will see this is the brainstem. And what is in the brainstem? There are three components. Where is the cochlear nerve entering? You see, the cochlear nerve would have entered the pontomedullary junction. Why? Because that is where we have the vestibulocochlear nuclei. So vestibulocochlear nuclei at the pontomedullary junction. Yes, vestibulocochlear nuclei at the pontomedullary junction. So as the cochlear nerve would have come here bringing the sound sensation, what is it doing? Most of the fibers, they cross the midline and some will run ipsilaterally. So most of the fibers will cross the midline and some will run ipsilaterally. Yes, most are crossing and running contralateral. So most are crossing and running contralateral. Where are they crossing? When they are crossing, there is a body here and that is called as the trapezoid body. So there is a trapezoid body because it is trapezium shape. Yeah. So there is a trapezoid body in the lower medulla. Yes, lower medulla. If you say it is, this is not lower medulla, this is lower pons. Lower pons. So this is the trapezoid body which is in the lower pons. And what is it doing? It is letting cross the fibers. You mean to say whatever information was received by this side ear is coming to pontomedullary junction is crossing to the other side. Contralaterally running. Most of the fibers run contralaterally. Yes, crossing in the trapezoid body. But then there is a nucleus also in between. Which nucleus? You see, the nucleus which we are talking about is called as the, yes, it is called as the superior olivary nucleus. So now there will be some superior olivary nucleus in the lower pons. Yes, SLIM, you know. So you're talking about SLIM, the superior olivary nucleus in the lower pons. Yes. Now, when you say there is a superior olivary nucleus in the lower pons, that is where the nerve fibers would have come. Yes, vestibulocochlear nuclei. Superior olivary nucleus. Superior olivary nucleus is also important for other reflexes like stapedial reflex. There is a question asking stapedial reflex relates with which nucleus? And the answer was superior olivary nucleus. It is working for stapedial reflex also. As the sound comes, it will try to activate stapedius muscle to reduce the sound intensity if required. Okay, what else it is doing? Actually, it is the auditory pathway, the first thing. Okay, then after superior olivary nucleus, what is happening? It will go to the inferior colliculus in the midbrain. If you say it is going to the inferior colliculus in the midbrain, the inferior colliculus in the midbrain is also an auditory pathway. Yes, it has nuclei, the neuron bodies. So this is which order neuron? See, first order neuron is the cochlear nerve, and this is the second order neuron from the superior olivary nucleus, and now you will have the third order neuron from the inferior colliculus. So three order neurons now. Yes, actually, first order neuron is the bipolar neuron, which is the cochlear ganglion. You mean to say spiral ganglion in the cochlea? Yes. So that was the first order neuron. Yes, having a peripheral process, central process. Right. And who is the second order neuron? That is the superior olivary nucleus having a neuron. And who is the third order neuron? That is the inferior colliculus neuron. And what is the communication between the superior olivary nucleus and the inferior colliculus there. This is called as lateral lemniscus. This is the lateral lemniscus. Why it is called lateral lemniscus? What is a lemniscus? Lemniscus is bundle of axons. And why it is lateral? Because it is running away from the midline. So it is running away from midline, lateral lemniscus. If it was running near the midline, it will be medial lemniscus. Yes, you remember dorsal column medial lemniscal system is near the midline. So dorsal column medial lemniscal system is near the midline. Yes, damage in the medial medullary syndrome, medial medullary syndrome. So this is lateral lemniscus called so because it is present laterally and it is some bundle of axon lemniscus. Yes. Auditory pathway, yes. L, slim. L, I, inferior colliculus. Now M, medial dentated body. So as for superior olivary nucleus, giving the second order neuron, yes. And second order neuron run as lateral lemniscus, yes. To synapse with the third order neuron, which is inferior colliculus, yes. And with the fourth order neuron, fourth order neuron is here in the medial dentated body. So can we go to the medial dentated body, now the fourth order neuron? Yes, let's do that. You know, this is brainstem, and above the brainstem, you will have the thalamus. So this is the thalamus, yes. And then there's a metathalamus. And what do you include in the metathalamus? There's a medial geniculate body for music and a lateral geniculate body for light. So medial geniculate body for music and lateral geniculate body for light. Is that so? Yes. Remember, the lateral geniculate body relates with superior colliculus. Lateral geniculate body relate with superior colliculus. Why? Because it is the light pathway, the visual pathway, and it will make sure that you are turning your head towards the visual information. You mean to say superior colliculus relate with the lateral geniculate body for light pathway, the visual pathway, moving your head, neck like that towards the light sources? Yes. And what is the inferior colliculus for? Inferior colliculus is relating with the medial geniculate body. Okay, so inferior colliculus is related with the medial geniculate body so that I move my head and neck towards the source of the sound. Yeah, you can say that like that. So inferior colliculus will make sure that I'm moving my head and neck towards the source of the sound. Yes, that is what it is for. Superior colliculus, inferior colliculus, they are moving our head and neck towards the source of light and sound. Yeah, that is what they do. But it is also in the auditory pathway. So inferior colliculus is also in the auditory pathway. Yes. And then it is medial geniculate body. Medial geniculate body will give you the fourth order neuron. And the fourth order neuron for the medial geniculate body, where is it going? You don't know. It is passing through the internal capsule. So as it is passing through the internal capsule, we have learned there was some lentiform nucleus here. Yeah, lentiform nucleus. It is passing under lentiform nucleus. Alright, this pathway, fourth order neuron, is now passing under the lentiform nucleus so that it will reach to 4142. That is 4142. Yes, that is 4142, you know. Slim 4142. What is S for? Superior olivary nucleus. What is L for? Lateral lemniscus. What is I for? Inferior colliculus. What is M for? Medial geniculate body. And what is 4142? 4142 is actually the 4142 is Haschel gyrus. If you say it is the Haschel gyrus, it is the superior temporal gyrus, it is the temporal auditory cortex. Temporal auditory cortex. So this is the temporal auditory cortex, the superior temporal gyrus, area number 4142, the Brodmann number, and Haschel gyrus. That's where the sound will be finally localized. Remember, the basal turn is for high frequency sound, and the apical turn is for low frequency, of course. So basal turn is detecting the high frequency, yes, and this apical turn is for low frequency, yes. That is also a question.